Hey everybody. Sorry, just silencing my phone. This is a quick little helper video for the Tuesday, March 31st review assignment. So starting off with I was going to say numbers 1 and 2, but I guess I can do those one at a time. So problem number 1, you're supposed to evaluate the expression once you plug in for x and y. It's telling you what to plug in for x and y. Once you do that, just make sure you're following the order of operations, whether you know that as PEMDAS or GERMDAS. GERMDAS would be G for groupings first. So I guess here in this example that we did in class, once upon a time, you would plug in 4 for y and -3 for x, and then you would do whatever's in the grouping symbol first. Okay. And then E in GERMDAS would be exponents. And the R, I believe, is for radicals, or roots, like if you were taking a square root. And then M and D, just like PEMDAS, is multiplying or dividing, or multiplying and dividing from left to right. And then AS is adding and subtracting from left to right. But the only sort of on today's assignment, I think that the biggest trap potentially could be if, like, you were doing x, like let's say on this problem it wasn't this, it was like x squared minus 4y. Let's just leave it at that. And so if you're trying to plug in or you're trying to evaluate x squared and x is -3, just remember that x squared will ultimately equal, let me actually write it out here, because technically you're supposed to be using parentheses. -3 as a quantity, I guess, squared, is +9. Okay? If you just plug that into your calculator without the parentheses, it wouldn't tell you the correct answer. So just remember that. Like, that's the biggest surprise trick, potentially. Maybe not. I'm not gonna say whether or not you're gonna have to deal with this, but that potentially, that's something you gotta watch out for. If I was just saying y squared here, then that's just 4 squared, and that's +16. Okay, but even if x was like -3 and you're doing x squared, that's going to be +9. And then if we were doing -4 times 4, it would be -16 here, plugging in 4 for y. And so this final answer of my new made-up problem here would be -7, I believe. And then as far as number 2 on our assignment, the biggest thing I want to remind you of is that you want to do all of this math first in the absolute value. Like, get the absolute value down to just one final number, and then and only then should you take the absolute value. Okay? Like here, over here, please, I don't even know if I want to say it, but don't take the absolute value now and say, oh, this means 1 plus y. No, not necessarily. Okay? So what was y? 4. So here you would first do 1 minus 4. Like, you would plug in 4 for y, do the 1 minus 4 to get -3, and then take the absolute value and get 3 for this part over here. Moving on, okay? Moving on to numbers. I know I misnumbered this on your paper, but there is no 3 and 4. So number 5, number 6, and number 7. Number 5, I don't really have anything here to show you on the screen per se, but number 5 is just giving you a slope and a y-intercept. It's pretty much the most ideal situation. Okay, so if they literally give you the slope and the y-intercept for free, you have your equation in like 2 seconds, because all you got to do is remember that slope is m and the y-intercept is b, and you're just going to plug those numbers in for the formula y equals mx plus b. Number 6. Okay, now I guess back to your screen here. So for number 6, what they're giving you is the slope and a point, and they want the equation. Now they might want the equation in point slope form, they might want the equation in slope intercept form, but either way, you can use this formula. Alright, so using this formula, you plug in 1/3 for m, and then you plug in the -6 for x1, and you plug in the 2, the y coordinate, for y1. And like I just said, and you don't plug in anything for y or x. So with what you're given, it's the perfect set of ingredients, okay, information, to plug into this formula. And this is how you do it. This is where you put all those ingredients, okay? Now a double negative, if you're subtracting a -6, that's the same as adding 6. So going from this step to this step, it was just, that's all I really did, was clean that up a little bit. Now, if all the problem wanted was point slope form, then you're done. This is it. But if the problem asks for slope intercept form, then you would just keep this going. You would next distribute the 1/3, and you would get y minus 2 equals, so what's 1/3 times x? Well, that's just 1/3 x. And then what's 1/3 times +6? That would be +2. And then you just got to finish getting y by itself, because when they say slope intercept form, another way to say that, another unofficial way to say that, is solving for y, okay? Because slope intercept form is y equals mx plus b, where y is all by itself on the left side. So we're just pretty much getting y by itself here. And the last thing we would do is get rid of this -2 term by adding 2 to both sides. So in this situation, you would end up with y equals 1/3 x plus 4 in this example. Okay? And that's what you need to do in number 6. Okay? Over here is just an alternative strategy that you might be familiar with, right? But if what they want is point slope form, then this is kind of counterproductive, this method. But anywho, number 7 on your paper for today is just like this example, where they want the now here they want the standard form, okay? But your assignment for today, I think, is just asking for slope intercept form. That's even better. So we don't really even need to take the extra steps to figure out standard form. So regardless, what they've given you is 2 points. They're giving you 2 points, and they want the equation. Well, the first thing you do is you find m. using the formula for slope. Okay? So you absolutely need m, and you can find m on your own. So m is 4. After you do that, now you can take your newly discovered m value and one of these points, okay, and plug them into this formula. So we're obviously going to plug in 4 for m, and I am assuming I chose this over here. Maybe I didn't. Yeah, it looks like I chose this one. Whoa, that was funny. Now, I could have chosen this, and I wouldn't blame you because this point has no negative numbers, but I think what I usually say in class is if we literally just got done calling this x1 and this y1 in this formula, right? Like in this formula, we actually were calling these numbers already x1 and y1. So why not keep that going here in this formula? So that's probably why I used these points here and not the easier ones. Now, dot, dot, dot. So just like the last problem, you would first distribute, because I think on our paper, again, they want slope-intercept form. So we would first distribute the 4, and we might as well clean that up at the same time. So this says really y plus 1, and the other side after distributing becomes 4x minus 4. And then we would just subtract 1 from both sides to finish getting y all alone. And if we subtract 1 from the right side, the negative 4 becomes a negative 5. Alright, and once again, perhaps you're more comfortable because of your background or whatever. Maybe you're more comfortable with this method, but again, this being standard form, if all they want is slope-intercept form, then you're done at this step. Alright, last couple of problems on your paper, numbers 8 and 9. This is how you can approach number 8. What am I doing here? You can break it up, so go ahead. I'm going to cover this up in a second, but, you can pause the video or go back in the video or whatever, but you can break this up, and solve it. But I mean, but you can leave it together and just add 4 to get x by. So what you're doing is you want to get x all by itself in the middle. Okay, and if you add 4 to all 3 parts here, you add 4 to the middle, the right side, the left side, you end up with, let's see if this works. It's going to work. You end up with 6 is less than 3x is less than or equal to 14 plus 4 is 18. And now to finish getting x by itself in the middle, you're going to divide by 3 to all 3 parts. And so you get this. So this final answer, which is still sort of in a smushed together double inequality, means the same as this. Either way, it's the same. Now, number 9, they're connected with the word or, and they're already 2 completely separated inequalities. Just solve each of them for, x. Alright, and just remember that if you find yourself dividing both sides by something negative, like let's say this was a negative 6k, and instead of dividing both sides by 6, I had to divide both sides by negative 6, I would have had to reverse the inequality symbol. So just remember that, okay?